Hi folks, Tom Affolter back here again, and today we're going to talk a little bit more about ANSI SQL, and we're going to dive into managing data. So up to this point we've looked at how to pull data out, how to do select statements, how to group data, how to go back in and do joins. But we really haven't looked too much about managing data. So what we plan on doing within this section is understanding three different types of statements. The insert statement, for inserting records obviously, the update statement for changing existing records, and then the delete statement for deleting out existing records. So what you're going to find out is in many cases Visual Studio, the tools that we're using, or Management Studio, will offer us wizards or helper tools that are going to make life a lot easier. Later, we'll find that when we're building applications in some of the Microsoft and Ruby tools, that they'll actually build the inserts, the updates, and the deletes for us once we point to a particular database. But it's really going to be important for you to find out that we're going to deal with what's called bound data and unbound data. Bound data would be that data that I just talked about that was automatically generated by whatever program that you're using. Those programs that build the inserts, the updates, and the deletes. But we also have to have the occasion to build what we call unbound data. And unbound data is where we go back out there and we do the hardcore approach. We actually write the code that physically connects to the database. We pass to it our statement. That statement is executed. If it's a select statement, that statement returns back data to us. If it's an insert or update or delete statement, it just happens and then completes. So those tools that we're going to find out that exist in Visual Studio and Management Studio are extremely powerful, but they're going to be very limited in what they do for us. So the very first thing I'd like to do is to start off by showing you Management Studio and the features that we had for adding records or deleting or modifying existing records. So let's just jump right over now to Management Studio, and I like to go down here and I'm going to open up a table that I've previously created under the T Affolter area, so I can, this is just my mess around tables if you will, so I can just go around and play. So I've got this table in here called customer. Let's go ahead and open up customer and see what it has in it. So I see I have a customer ID, which is a primary key. It's an integer, so I can probably guess that it's going to be a counter field or an identity field. And then I have a last name, a first name, address, city, state, and then I have remarks. So if I want to go ahead and add additional records, or I want to delete records in this table, what I can do is simply do a right click on that table and move down. It says edit top 200 rows, and go ahead and click on that. Now what it's going to do, it's going to open the table up as we did before, but now I have the ability to go back in and add records. So what I like to do right now is I'll go ahead and add my own record in. I'll put good member here. Now, as soon as I click underneath here, assuming that this is an identity field, I get the number automatically assigned to it. So notice that when I did an insert statement, I didn't deal with the identity column. In fact, I ignored it entirely and let the computer manage it for me. So if I wanted to, I can continue to add additional records into it, or I can come back into a record that I already have, simply do a right click on that and identify it as a delete, and I could delete. What did it do there? Let's try that again. Delete. Yes, must have hit the wrong thing. Now it's going to warn me and tell me that I can delete the record out. Yes, it's deleted. Now if I wanted to, I could come back in here and let me put the record back in again. Okay, so now I've moved out of it. What I can do now is go back into that record. Again, I could have done it by, let's close this out and just prove this. Let's close it, let's come back in, do a right click, and this time I want to edit the top 200 rows. Selecting the top 200 rows will not give me what I'm looking for. It will just list the data out. Editing it will allow me to come back in here, and now I can highlight a particular record if I wanted to and make the changes to my data. Now, this is a very powerful feature, but the fact is it's going to be used very little. You don't normally go back in and edit records in this format because, again, the program is going to set constraints, tell you how to type that data in. You really want to avoid going into your raw data to either do the deletes, the updates, but you as a administrator will occasionally have to go back in and modify data or make corrections to data input mistakes. But one of the challenges that you're going to see here again is if you have more than 200 records or 200 rows, you can't get to those records down below. This edit feature only allows us to do the top 200 rows. Now if I went back up into tools and options, I could override that 200 and make it 400 or 5,000, but again, I have to tell it exactly how many to use, and that's not going to be the best way to do it. Even though I can use those tools to edit, as a power user, I'm probably not going to use those. So let's continue on and show you why. So the very first statement I'd like us to take a look at will be the insert statement. And the insert statement has a couple of different formats that we need to understand. It has the basic format that we're going to see here on the top, and then we have a little bit more detailed format on the bottom. They don't do exactly the same thing. The bottom one, you'll find out, is a little bit more flexible. So let me explain what's going on here. What we have is we have an insert into the table name that we want to insert. We put the keyword values here, and then in parentheses, we then put in all the values with the correct data types, meaning that if I'm putting string data in, I have to put an apostrophe around it. If I put numeric data types in, I don't put apostrophes around it. But the order of which this data exists right here, with the sole exception of a primary key that's an identity field, which I told you a minute ago you ignore, you have to put the data in the exact order that you see here. So for example, if I went back over here to this table and I wanted to insert a record into this right here, so let's do a new query here, and I wanted to insert it into customers using that method that I just showed you. Let me jump back first to my slides, and I know I have an example right here. So you'll see when I'm on this slide, I'm inserting into a table called persons the values, and I'm putting in Hetland, Camellia, 103rd 2nd Street, Spokane, and that has to be the order of which the tables exist. Right there. The first field has to be the last name, or at least the first non-identity field has to be last name, then first name, then address, and then city, in that order. I could, in essence, have state, zip code after that, as long as they're not required fields. Let's go back and try this one out. So looking at this table right now, I've got this customers table, so I'm going to insert, and let's go back. I'm going to insert into customers values. Insert into, in this case, it's customer, singular, then the keyword values. And now within here, my data has to be last name, first name, address, city, state, and remarks in that order. So that's exactly what I'm going to do. So I'm going to start off with last name, apostrophe Flintstone, first name, Fred, the address is 123 Bedrock, or excuse me, we'll do it Rockway. Then the next thing is the city of Bedrock. And then I will put Fred in Washington. And then I'm going to give Fred a 99212 zip code. Okay. So again, they should match one for one down the line here. I'm going to check it. It says everything worked okay. I'm going to execute it. And it says one row affected, and let's go back and list our data out. Now I'll just select the top 1,000 rows, and now I have Fred Flintstone at 123 Rockway, Bedrock, Washington. So that is the one method, the first basic method that we're going to deal with, and that is the literal method. You put the data in the exact orders of which you see them, just as you see right here, excluding a identity field. Now, had that first field that we had out there been a primary key, but it had not been an identity field, kind of like the players table in baseball, we would have had to include it because it wasn't generated by the computer. Let's come back in and take a look at the next method, because a lot of times what you're going to find is you don't want to list out all the fields. You might have 50 fields in your table, and of those 50 fields, only, let's say, 5 of them are required, and the other 45 may be filled in or may not be filled in. And you don't want to have to go through and fill in default data for all of them. You're going to use the next method. And the next method is the column-specific insert. And what it does is a little bit different. When you insert records into this one, you start off with the field list. So right after insert into persons, I say I'm going to insert a last name and an address. And then after that, you'll include the keyword values, and then in parentheses, the first value and the second value. If I've got two values that I'm changing in my insert statement here, then I obviously have to have two values that I'm putting in this case, Smith and 999 Longfellow. I could have put them in exactly the opposite. Nothing to say I couldn't, using this method, gone back in and said insert into persons, address, comma, last name, values, and then I would have put 999 Longfellow first and then Smith second. So the order of the columns in this technique doesn't matter at all, as long as they match. There is one thing that you have to keep in mind, and I'm sure I'll bring that up here in just a second in my PowerPoint slides, but whatever my table requires as must-fill fields, those fields that can't be null, they have to be included in this. If I exclude one of those columns in here that have to be filled in, I'm going to get an error when I try to write the record, and it's going to tell me that particular column wasn't filled in and it is required. So again, that's part of that data integrity that we talked about, where the data has to be exact. We want it to match. We want our rules to make sure that it matches. So let's jump back over to this table that we had before, and let's investigate this a little bit in the structure. So it looks to me like all these fields down below here can be null fields. They don't have to be, any of those fields have to be filled in, but the customer ID field does have to be filled in, but again, I can ignore that field. So if I wanted to do something similar to this, so let me not pain you to have to watch me type through this. Let's decide now that we want to put in Wilma's record. So using this other technique, then what I would do, and let's say that I don't want to put in Bedrock, Washington, okay, because they're not required. Now, of course, it's not going to put anything for them. It's going to leave them as nulls. But I just want to prove that I can do that. And in fact, what I think I'd like to do is let's move Wilma right here in front of the last name. So we're taking these fields and we're putting them in a different order. Now, if I try to put these in right now, it would work. It would work, but what it would try to do is it would put Wilma in for the last name. I would have, for the first name, I'd have Flintstone, and then I'd have an address for 123 Rockaway and then nulls for the rest. But down here, what I want to do is put in the correct field list at this point. So what I'd like to do is I'm going to have, it looks like F name, L name, and then address. Okay, and then I close out my parentheses. So now remember, oops. Okay, now remember that these fields match one for one. So the first name matches Wilma, the last name matches Flintstone, address matches the 123 Rockaway, and then we didn't put those other fields in. We didn't put in the city, state, and remarks. Let's see what ends up happening because of that. So I check it, it says it's in pretty good shape. I execute it. Says it worked. Let's come back over here and let's take a look at the records. And now you'll see that I have Wilma in here, but for those fields that weren't given, I have nulls. Remember, a null is not the same as an empty. It doesn't say that Wilma lived in no city. The null says I don't know what city Wilma lived in, state, or zip code. And that's why we put nulls in, because later we might want to count how many people we have that have zip codes. We might want to count how many people or average out a certain field that's a numeric field, and we want the nulls to be excluded. Remember, in an aggregate function, all those nulls are excluded. So hopefully this part makes sense. Let's take a look at a little bit of the rules and some shortcuts here. You can insert into a table, and you can also insert into some views. Now, what dictates whether you can insert into a view or not is whether the view is a join. Probably not. And if you have a view that has all the required must-fill fields in it, then you can insert through a view. Now remember, you're not inserting into the view. You're using the view, you're inserting into it, but it actually will go into the underlying table that view is made up of. But you can only insert a view if that view has all the fields, the must-fill fields that are required. If you don't, again, it's going to error out. Information with the insert much masked respective columns data type. So you need to make sure that if you're putting in string information, you put apostrophes around it. If you're putting in numeric or Boolean data that you don't. And remember, a Boolean data will be entered as a 0 or a 1. 0 being false, 1 being true. Data must match the constraint or an error is going to be returned. So we talked about previous in creating a table, and I talked about setting constraint ranges of numbers. For example, salaries have to be a certain range, or a street direction has to be north, south, east, or west. When you're inserting data with this, that same rules are going to be upheld. If you try to put in a non-north, south, east, west, or blank, you're going to get an error if the constraint does not match that column, and that's what you would expect. You can only insert a single record at a time unless you're going to use a select into statement, which we will take a look at here shortly. But normally you're going to insert one record at a time, and most programs are going to expect you to insert one record at a time as well. Now you can also use a identity field. Well, again, this is just going to talk about what I said before, and that is if you have an identity field, you can just skip it entirely. So I got a little bit ahead of myself before, but better review than not at all. This reiterates the fact that I didn't have to deal with the int ID PK. Now before I go on, I should also mention that that is a setting of the server. It's a setting of the server. So if whoever set your database up went back in and they didn't set it up to allow inserts into the identity fields automatically, then you're going to have to use another method. There is a command that you can insert before you execute your insert statement that says turn off the primary or the identity field. You insert the record and then you can turn it back on again, and it will allow you to get away with that. But in most cases, you'll never have to worry about that because by default, you're going to find SQL Server deals with it the way we're looking at right now. You can also use a keyword default. So if you have default data set up for a respective column, as we experienced when we were looking at that create table, you can use the keyword default, and what it will do is just plug in whatever the default data was for that respective column. In C# or Visual Basic, I told you the importance of string concatenation and manipulation. So we talked about later our responsibility will be to build an insert statement or an update or a delete statement dynamically. And then, meaning dynamically, we'll pass into the record that needs to be deleted or the name that needs to be deleted or inserted, and it will automatically build that table for us. But what we're going to find out, and hopefully by now you've listened to that video I have on SQL injection, that's going to open up the door to some problems, and we have to deal with it from a programming standpoint. So what I'm going to show you next is just an overview of it. We'll talk about this when you get into programming class later, but I do want to talk about how we would maybe build a string for within, in this case, C#. So let's assume that I've got an insert statement and I've got some fields that are on in an application that I wrote, and I want to dynamically add those records that the user put in into a table. So I got to build a string. So what you're seeing on the screen here is I'm building an insert statement. This also reiterates the importance I told you about before of using apostrophes as opposed to quotation marks. So everything that you see in yellow right here would be the command itself. So look what I'm doing here. I've got a string and I've got the literal insert into table test the values, and then I've got that left parenthesis. So remember now, I'm going back to that example that we had before where I'm not using that column list here. I'm putting the elements in the order that they expect to see them come in. So again, notice, and that, by the way, before I go on, that is an outdated slide. Let me fix something here while I've got you folks here. I've got a slide that I need to repair. Hold tight, because this slide is a Visual Basic slide and not a C# slide. And here we go, we're back. So let's go back and explain what's happening here. So this is a literal, it's building, and you'll see down below here, this is an example of what's happening. This is the statement on the bottom that I hope to build. So I want to get Tom and Jones and Spokane from variables, and I'm using strFname, strLname, and strCity, and they're holding that data. So again, notice what I'm doing. I'm creating this portion of it in yellow, which is a literal. That's that part right here. Then I'm telling it to put an apostrophe. There's that apostrophe right there. Put in whatever strFname has stored in it. So let's assume it has Tom in it. So it's going to put the keyword Tom. After it, it's going to put an apostrophe, a comma, and another apostrophe, and notice how they're within the quotation marks, so they're literals. Ultimately, this is the statement that's going to come out. We're going to execute that statement, and assuming that this is the order the fields were created, I've now generated a statement. The problem with this is a prime exploitation for SQL injection. SQL injection would say then that I could actually go back in there, and a little bit harder on an insert statement that is a select statement, but I could modify your code if I could get to this point and perhaps even fill up your hard drive or damage your data. So you got to be really, really careful on how we're building these particular statements. Here's an example of the proper way to do it, and I'm not going to spend an enormous amount of time on here explaining, but this is actually in the C# world using what we call ADO, ActiveX for data objects, which is Microsoft's technology. They've got these objects that make it easy for us to connect to a database. And this very first object that we have here is a command object. And with that command object, I'm going to put into it the command that I want. So notice here, I'm creating what's called my command text, and I'm telling it my text from my command is going to be insert into members values. And notice what I'm doing here. I'm using placeholders, and these are what are referred to as parameters. And so I'm saying this is where the name is going to go, this is the address, city, state, and this is where the zip's going to go. And then I create parameters, and I say, you know what? @name is going to be equal to whatever's in this textbox.text property on my current application, and address is equal to this information, etc. down the line. Now the advantage of doing this is that this parameter object has built-in features that will block SQL injection. It will prevent somebody from going back in and adding the things that you should have seen in that previous video that allow SQL injection to occur to hijack a select statement or hijack an insert statement on it. If you don't use these, then you're at risk. And you're going to find that most programming languages will have something that will let you get away with this, but you're still going to find to this day that there still are programmers out there that will use this method in order to write their apps. And I'm not going to tell you that using this method is inappropriate. It's appropriate if you're using it into a place in your application where there's no user input, in this case of str, fname, or lname, or city. Meaning it's not coming off of a login or something where the user is feeding directly into the values. But I would suggest that you always get in the habit of using this anyway, because it's the clean, safe way of inserting records. But again, you're not going to have any of this on any quiz or any test. I just wanted to show you how we would prevent some SQL injection. Now we're going to talk a little bit about some other statements, the update and the delete statements. The insert statement isn't really overly risky. You can insert bad data, but it doesn't cause you to damage any other existing data out there. And what we're going to find out is the most dangerous statements that we have, and actually the easiest statements to use, which also makes them very dangerous, will be the update and the delete statements that we're going to come across right now. And one of the problems, and you're going to hear me reiterate this again throughout the remaining part of this lecture, is there is no undo feature. If you were dealing with Fox Pro or Access type databases, when they delete a record out, they mark them for deletion and ignore them, but they don't physically remove them until you go back in and do what's called a pack. And when you pack your database, you're telling it, rebuild a database and get rid of all those records that were marked for deletion. But anytime during that process, you can undelete a record before you pack. SQL Server's not that way. SQL Server, when you delete a record out, you delete a record, and there's no getting it back unless you have a backup of that record. So you want to be extremely careful on how you implement these commands, because I've had employees before accidentally go back in and while they're building a delete statement, test out a certain feature and delete all of my data out. So one of the things that you're going to find out that would be more than appropriate is before you go back out and you delete records out, make a copy of that table using that select into feature, so that if you do damage your database, you've got a copy of that. But let's continue and talk about that a little bit more. Data is modified within a database using the update command, or the SQL update command, and it's written out where you say update the table name, and then you say set this field equal to this value. And then you're going to want to almost always put a where clause. If you don't put a where clause in it, this is the danger. You're going to change every record that has that field in it. So let's continue and talk about that a little bit. Here's an example on the screen here where I've got a fictitious table called table store info. And in here I've got three different columns. I've got store name, I've got the sales amount, and I've got the date. And what I want to do is I want to update the table, and I want to set the sales for Los Angeles, but not both Los Angeles, only the one that is January 8th of 1999, this sale right here. I want to set that sale to $500. So the update statement is extremely simple. You say update, the table you want to update, set sales equals, in this case, and the new value. Had I left this alone and simply said update, table store info, set sales equal to 500, and I accidentally executed it, every single one of these records would have become 500, and there's no getting them back again. So you've got to be very, very, very careful. One of the techniques that I will use is before I do anything, it's the where clause that will dictate what records are deleted. I will create a select statement to list out the where clause to show me which records would be deleted. So had I done a select statement where store name is Los Angeles and date is January 8th, 1999, only that one record would have been returned back to me, and I would have known that that's the appropriate record to change. Then I would have gone back in and changed it to an update statement, as we see right here. So again, it's a very, very powerful statement, but if you did update, table store info, set sales equal to 500, again, major problem. Major problem. You don't want to do that. Be very, very careful. I'm very happy that I don't have to create a lot of update, delete statements in applications that I create, only because of the risk to my data. And I'm very, very careful about making backups before I do anything. So updated data must meet the updated field constraints. So again, just like when you're inserting data, if you're going to change data, what you change it to has to match those constraints as well. You can update more than one field at a time in a single statement. So what I could have done here, and let's see, I have it here, so we'll take a look at one in just a second. The updates where clause can be a simple logic or it can be complex. So, and it's just like anything else. When we do a select statement, as complicated as that where clause is, it can be the same thing here. And again, you want to use apostrophes around string and date time data, or at least square brackets around date time data, just to make sure you keep it different than numeric data. Students will sometimes want to go back in and put a date in like 05/01/2017. They'll put it in just like that without apostrophes, and it will want to take 5 divided by 1 and divide it by 2017, and that's not what our intent was. And then it will give us a type mismatch error or data error saying, wait a minute, the results of this answer don't fit in to the date time field that you're dealing with. Here's an example of an update statement here that uses 2 different values. So in this case, we're saying update table store info. We have to use that set keyword, set sales, that's the column that we want to change, equal to default, but we only have to use set one time, and then set the date column equal to null. Now this is what we're going to use that will allow us to change an existing date to a null. You don't do that very often. But I told you before we can do it, and here's an example of how we can go back in there and override a date, and it would basically take this January 8, 1999 and make it into a null date. Let's jump over to our date and just take a look at what we've got here and play around just a little bit here. So inside this table, let me close out what we've got right here. Let's close out all of these as a matter of fact. Okay. Well, I could use this one. Let's rerun it again. And there's my 3 pieces of data. So directly underneath this guy, what I'm going to do is I want to change the address of Thomas Affolter from 123 Main to 123 First Street. So in order to do that, I'm going to say update the table name that I want to update, and I'm doing this below my select statement now, and I'm only going to highlight the update statement. So I'm updating here the customer table, so update customer. Now the next thing I want to do is I want to use the keyword set, and I'm going to set now address equal to 123 Main, where customer ID. You probably want to use the, if you have access to it, you want to use the customer ID field, because there might be, in this case not, but there might be more than one person with the last name Affolter or the first name Thomas together. Not again real likely, but you don't take that chance. Especially if you're writing a program, because you don't know if at one point it's going to be Tom Affolter or the next moment it's going to be a Dave Jones, which is going to be far more likely to have duplicates. So I'm going to use a customer ID. where the customer ID, primary key, PK, is equal to 2. Now let's see if I got this. Nope, it should be an ID, like that red error message. Let's check it to see if the structure is correct. It is. And now let's execute it. Ooh, before I do that, let me rerun this. It was main. I want it to be first. There we go. Check it. Execute it. There it is. Let's rerun it. And there it is. It's first. Very simple statement, the update statement. The only statement probably easier than the update statement will be the delete statement. So you could have updated multiple fields at the same time. I could have said I want to change the address back to main, and I want my first name. So I want F name back to Tom. So 2 different fields at the same time. Check it. It says it worked. Let's execute it. And let's rerun our data. And there it is, Tom, and back to main again. Pretty easy statements to utilize. Update rules. So again, we have to have the set, but the set is only used at the very beginning. After that, we just use a comma and then the field values we want. You can use a value of null or default if you choose to. So you can say where date is equal to null, or you can set your sales equal to default, as you see on the screen right here. If you don't have a default value, you're going to get an error. It stands to reason. So here's an example in here where we went back and we excluded the where clause, and notice what it did. If you exclude a where clause, everything here was going to be set to 0 and null, and there's no getting it back. So be very, very careful. Next statement we're going to take a look at is the delete statement. And we remove records from a table using the delete command. So in this case, it's extremely simple. You say delete from what table, and you have a where clause that tells you what records to delete. What I want you to be very careful of is don't get confused between the drop command and a delete command, because Microsoft makes it a little bit more complicated. If I'm dealing inside of a query, then I drop a table, a view, or a store procedure. That physically deletes that entity out. It deletes the table, it deletes the view, or deletes the store procedure out. Whereas the delete command deletes records from within a table. Deletes records from within a table. Now where it gets confusing though is right here. If you go back over to customer and normally you would type in drop customer over here, or drop table customer, and it would drop this table out. But if I right click here, this is where it gets confusing, because now it's a delete command from within the menu. So just again be careful so you understand the difference between the two. So to delete records out, you simply delete. So let's go back here, delete from. So delete from what table, and a where clause. This case it's deleting from table store info where the field name is equal to, so the store name field is equal to, and that which probably should be a store city, but it says store name is Los Angeles here. And in that particular case, it would delete both of these records out because they both have a store name of Los Angeles over here, and I would end up with only the 2 records left over, San Diego and Boston. So again, it's a very, very simple statement to deal with, that delete from store info. If you simply typed in delete, let's go back here, delete from store info, you've now deleted every record out, and there's no getting it back again. One other thing that I might point out that might be of value to you is the fact that you'll notice up here at the top, when I use the builder, it built this comment at the top. But watch what happens when I delete most all of it out. I'm going to delete this guy out right to here. Now what happens is if I run my statement, I get nothing back because it's telling me I've got a comment on, but I don't have a comment off. Now this is kind of my fail-safe here, because if I was to go back in here and accidentally leave delete customer on here and I hit execute, it's not going to delete because it thinks it's one comment. Whereas if I now highlight the statement, I can now execute them because they're highlighted. See how that works? I can highlight them. So if one of the things that's really common is people that edit statements will put this comment at the top, and instead of relying upon the run to run everything, they expect you have to physically highlight it to execute it. That way you cannot accidentally run that delete statement. So just a suggestion, a technique. So if no where clause is included, again, all records are going to be deleted. There's no undo once you delete those records. The conditions must be a complete Boolean statement. Just as always, it's like any standard where clause. It has to be complete. Deleted records must meet relationship constraints. So this is where I talked about before. If you go back in and you relate tables and you physically in that table definition tell it this is a primary, this is a constraint, this is a relation. I'm not talking about when we go back in and we build them and we build our relations in our joins, but if you physically go back into design of your table and you build what is called a foreign key constraint, then what will happen is you cannot delete a parent out that has children. This statement will prevent that from happening. And that's a good thing in a lot of cases, but it's also restrictive as we talked about before. You can delete records in a view, but those records that you delete in a view, it should be a single level view. Don't do a join. I don't recommend you delete records out of a view because it can be problematic. You'll find out that it's going to be easier just to delete them by hand. Also, if you want, we looked at creating a spin-off table, and I showed you that we can do a select star into something and create a table. In this case, we're creating a new table called new table, and it's going to only copy in those records where the type member is equal to life. It's going to copy the exact structure into that new table with the exception of the foreign key constraints. You'll lose your primary key and you'll use your identity fields, but the data and the data types will copy across exactly. Now, we can also have a shortcut with the insert command. So what I can do is, assuming in this slide here that I've got two different tables, I have to have a table called merge table previously existing. It will not create merge table if merge table doesn't exist as what happened in the select into previously. So in this case, merge table has to exist. It has to have the exact structure of whatever that table name is on the right hand side, and I can move records into it. Now when I say it has to have the exact structure, only because I'm doing a select star here. But if this table, for example, has only 3 columns in it, and those 3 columns are included over here in my field list, then I can insert into merge table those 3 columns. Let's take a look at that and we'll close this section off. See if I can make this work for us here. So, first thing I want to do is I'm going to create, we talked about this before, I'm going to create another customer table, and I want that customer table to have the exact structure the customer has in it, but I don't want any records to be copied into it, just to prove it. So let's do this. I'm going to delete this out. I'm going to say select into, let's try this. I want to select, let's try only last name, so select last name, first name, into customer names. Okay, now I'm going to do a where 1 is equal to 0. And I need to put a from here. So let's do from customer. There we go. So what I'm doing is I'm copying a structure. The records, there will be no records that it copies. Why? Because I'm telling it the only records to copy is if 1 is equal to 0. There are no records where 1 is equal to 0. It's impossible. So what it will do is it will give me a new structure called customer names. So let's prove that. Check it out. It says it worked. It says it ran here. Let's customer name. So that's what was created. Let's open it up and take a look. I've got 2 columns in here, last name and first name. So now what I'd like to do is I'd like to populate the customer names with all the customer names that exist in this customer table here. So again, let's go back in and let's take a look at all the records. So there's 3 records in here, and all I want to do is create into this new table and copy just those 2 fields in right here. Okay, so what we're going to do is we're going to use, oops, let's jump back around here. We're going to use this structure, insert into the table, and then a select statement at the end. Okay, so let's try that. There they are. What I want to do is I want to select L name, comma, F name from customers. And then run that one. Let me make sure I got that one right. From customer. Again, there we go. And now I'm going to take that information and I want to put that into customer names. So I'm going to insert into customer names that select. Is that customer names? Yes, customer names. Select. And let's check that and see what's going to happen. It says it's okay. We'll execute it. It says 3 rows were selected. Let's come back into customer names and see what we end up with. Select top 1,000 rows, and now I've only got those fields that were filled in. So it gives you an example of how we can use that insert. I don't use that enormous amount of time, but I have used it occasionally in programming, and when I do need it, it's a slick feature for copying records back and forth. Let's get back to our statements here. And that pretty much concludes the inserts, the updates, and deletes. And if you think that these statements are very simple, it's because they are very simple. But along with that simpleness also comes a lot of risk. So you want to, again, be very, very careful. All 3 of these commands can be dangerous. You can insert the wrong data, you can update the wrong data or the wrong value, or you can delete the wrong data or wrong values. You can insert to all records, or you can delete all records out. So again, be very, very, very careful, folks, and play around with it. Use that technique I suggested before, where you do select first to make sure that you're selecting the records you do intend to update or you do intend to delete.